Okay, so 7.2 is going to be multiplication and division of rational expressions. And so when we are talking about rational expressions, we're really just talking about fractions. And either we're talking about all numerical fractions, like our first example, or we're going to have fractions that have an actual expression, like x plus 2, or a quadratic, or a polynomial or some kind. The most important thing about our rational expressions is that we will have spots. We will have what I coin as trouble spots. And these trouble spots are where the denominator equals 0. And I know in 7.1, your first set of homework problems were just identifying where those trouble spots were. Where could we not let your variable equal a specific number? And so that was covered in 7.1. And today we're not going to be quite as concerned about that, and we're going to do more of the multiplying and dividing. But regardless of if you were dealing with just numbers or you're dealing with expressions where you have variables at play too, it works the same way. When you multiply fractions, you multiply straight across the top and straight across the bottom. And then it says with b and d not equal to 0, and that's because we don't want our denominator to go to 0. And that's true whether a, b, c, and d are all numbers or we have variables at play. There's two different ways kind of to approach these problems. The first is where you do the multiplying, and then you do the simplifying. And I usually refer to that as simplifying on the back end. And there's nothing wrong with that. I do find that that typically makes you more dependent on your calculator because oftentimes you get larger numbers. So I typically do my simplifying first before I do my multiplying because then I have smaller numbers. I'm not as dependent on my calculator. And usually if I do it all at the front end, then once I've done the multiplication, I'm done with the problem. And as you'll see, simplifying first, especially when we have expressions, is a lot easier of a format than doing it the opposite way once we actually have variables at play. So we're going to do a whole bunch of problems today. There's not a lot of notes. We will do a whole bunch of multiplication problems, and then we will shift gears and we'll talk about how we divide using rational expressions. This first one especially, if you want to see a bunch of problems worked out this way, there's a couple of lecture videos on the YouTube for my Math 20 site. 1.3 in Math 20 is all about how to add, subtract, multiply, and divide fractions. So if you need just a general overview of how to do anything with fractions, that is a great video to go watch. And there's also some videos in Chapter 2 of Math 20 where we break down how to add, subtract, multiply, and divide using expressions a little bit more. And so if you want some refreshers, I would recommend going to watch those. So our first example is just numerical, only numbers. So we have negative 8 over 27 times 9 over 14. Now, like I said, you can multiply straight across the top, straight across the bottom, and then do your simplifying. Or you can simplify before multiplying. So if you simplify before multiplying, what we end up doing is we kind of break apart our numbers into factors. And we say, okay, what times what will give me 8? Or negative 8, since I have the negative on top. Well, I know that negative 4 times 2 will give me negative 8, so I split it. 27 is the same thing as 3 times 9. 9 is, since I have a 9 down here, I'm going to leave the 9 on top. And then 14 is 7 times 2. What I'm trying to do is I'm trying to get similar numbers on top as on bottom, because if I have the same number on top of a fraction as I do on the bottom, I can cancel them out, and I don't have to multiply them at that point. So since I have a 9 on top and a 9 on bottom, they can go away. Since I have a 2 on top and a 2 on bottom, they can go away. So now look, the only number left on top is negative 4. And the only thing left on bottom is a 3 and a 7. 3 times 7 is 21. 4 has nothing in common with 21. It is completely simplified. You would get the exact same answer if you multiplied negative 8 times 9, which is negative 72, and 27 times 14. 27 times 14 equals 378. Here's the problem. looking at that, I'm like, those are two really big numbers. They're kind of obscure. Off the top of my head, the only thing I know that comes out of them is a 2. And the only reason I know that is because they're both even. And so I can take 72 divided by 2, and that's going to give me a negative 36. And 378 divided by 2 is going to give me a 189. So I simplified it a little bit. And here's the risk you run if you simplify on the back end. Many of you would probably stop at this point because you have an even over an odd. But we need to double check and make sure nothing else comes out, because obviously 2 doesn't come out. I know the top number is divisible by 3. 9 plus 1 is 10. 10 plus 8 is 18. So this is also divisible by 3. So I can divide both numbers by 3, giving me a negative, 12 over, divide 198 by 3, 63. And then I would do more division. Again, I know both of these are divided by 3, which does take me up to the negative 4 over 21. Both ways do get you to the exact same answer. Both ways are mathematically sound. The only issue is if you decide to go this route, if you're not good at spotting what gets pulled out or factored out of these larger numbers, you'll probably stop somewhere before you're actually to the final solution, and then you're going to get it wrong. And that's why I like to do all of my simplifying on the front end, because then I eliminate that possibility. And then the numbers are generally smaller, and I can double check to make sure, did I actually pull out everything? If I forget something, like if I would have forgotten, I don't know, the 2, I would have had negative 8 over 48, or 42, and that's a little bit easier to see that they have a 2 in common. But either method works. Either method is totally fine. Do we have any questions on this first one before we start adding in variables? All right. Here's another one. We have 3x squared over 2y times 4y to the third over 3x. Here we are multiplying two rational expressions. We don't call them equations because we don't have any equal signs. These are just expressions. You are not solving in any of these problems to try and figure out what the variables are. All we're trying to do is simplify. And again, you can multiply straight across the top, straight across the bottom, and then simplify on the back end, or you can simplify on the front end. Because when you're multiplying, really from the very beginning, you could just extend that division bar all the way across, and you've already been, like, you have your top and your bottom. And the way that we cancel is we say, what does the top have in common with the bottom? Tell me something the top has in common with the bottom. Anything. 3x. A 3x. That's exactly right. Because this x squared is the same thing as x times x. And so I can mark out the 3, and I can mark out one of my x's. Is there anything else that the top has in common with the bottom? 2y. A 2y. 4 is 2 times 2. And y to the third is y times y squared. So I can cancel out a 2. I can cancel out a y. So that would leave me with an x times a 2 times a y squared, and there's nothing on the bottom anymore. So that means my final answer would be 2xy squared. When you're doing these problems, you're going to get pretty nice answers. You're not going to get stuff where you have 2x to the 85th plus 7y to the 13th. Like, you're going to get relatively small answers because a lot of the stuff ends up canceling out. And that's especially true when we get into some of the bigger, harder problems here in just a little bit. All right. C. we have x minus 5 times 3 over 4x squared minus 20x. The x minus 5 isn't actually a rational expression, at least written the way that it is. Notice there's no denominator, but you can make any whole number a fraction or a rational expression by doing what? Put it over 1. That's right, we can put it over 1. We just magically made that into a rational expression. So we do have a rational times a rational. Remember when we learned the different types of numbers, that whole numbers and integers were part of the rational numbers, even though they're not written as a fraction, because we can write any of them as a fraction by sticking them over 1. Now, when it comes to these problems, we're going to rely a lot on our Chapter 6 material on how to factor. But here's a helpful hint. If you have a binomial as any part of your rational expression, so I have this x minus 5, I'm going to tell you that odds are that's probably going to cancel somewhere, and we need to just be able to factor some other polynomial or binomial, and we will get another x minus 5. So if you don't know how to factor 4x squared minus 20x, odds are it's going to be x minus 5 times something. So use the other information or the other parts of the problem to help you learn how to factor more efficiently, is what I'm trying to help you see. So this first one, nothing changes. It's already in its factored form. But if I look down in the denominator of my second rational expression, I have a 4x squared minus 20x. What do both of these terms have in common that I can pull out? 4x. And notice that will leave me with an x minus 5 inside. You can always check by distributing to make sure it's correct. But since I have an x minus 5 on top and an x minus 5 on bottom, they cancel, leaving me with just a 3 over 4x. So when you have rational expressions with binomials or polynomials and things like that, I strongly discourage you from doing the multiplication first, because if you did the multiplication on top, you would distribute the 3 and then you'd have 3x minus 15 over this, and it's definitely a lot harder at that point to see what's in common with the top and the bottom. Do we have any questions thus far? Need any clarification? Let's do x plus 2 quantity squared over 6x squared times 3x over x squared minus 4. Each of our examples are going to get a little bit more complicated or have a little bit more of our Chapter 6 material involved. So before I do my multiplying, I'm going to do some factoring and try and get some common factors on top and on bottom that I can cancel out. I'm going to write the x plus 2 quantity squared out a little bit. That way, if I have another x plus 2 on bottom that I can cancel, it's going to be a little bit more easy to see. On this top right fraction, I have a 3x. I notice on the bottom left I have a 6x squared. Well, 6x squared is the same thing as 3x times 2x. Again, I'm using the other parts of my problem to help me factor so that I can see where things are going to cancel. And then this x squared minus 4, does anybody recognize what this is? That's a difference of squares. That was one of our special factoring things from chapter 6. We have something squared minus something squared, which means it factors into x minus 2 and x plus 2. If you didn't recognize that it was a difference of squares, hopefully the fact that there was an x plus 2 on top would help us to identify that it's probably going to factor to an x plus 2 somewhere down there, and then just figuring out the other part. Again, when you factor, you can always use FOIL to go backwards to double check your work. So I do have an x plus 2 on top and on bottom. I have a 3x on top and on bottom. So that leaves me with an x plus 2 on top and a 2x times x minus 2. Now, I went through Pearson this morning and I did all of the homework. They specifically request that when you do your problems, you leave them in the factored form. So you won't have to do foiling, you won't have to distribute that 2x or anything in order to get your answer. This is the way that they want you to leave your answer in Pearson. Once you've canceled out everything you can, you're done. Questions? We've got 2 more multiplying ones, and then we'll move on to division. All right, this one's one of our big ones. 2x squared plus 5x minus 12 all over 6x squared minus 11x plus 13 times 3x squared plus 2x minus 1 over x squared plus 5x plus 4. Tell you what, if you didn't fully master the factoring bit in chapter 6, you're going to get lots of practice in chapter 7. Lots. And I told you there's lots of different ways to factor. I use trial and error. Typically, if you like a box method or something like that, you are obviously more than welcome to use that. One thing I would say is when I approach a problem like this where I'm going to have to do 4 different factorings, a lot of times I'm going to look for which one looks to be the easiest one to factor, and I will start with that. Because I know, based on all these other problems, that a lot of stuff is going to cancel. And so if I can factor the easiest one, odds are that's going to help me to see some of the factors of the other ones a little bit quicker. And I won't have to do so much guessing and checking. And so if I'm looking at this bottom right one seems to be the most basic. It doesn't have a coefficient out in front of my x squared. They're both positive. Like that seems like the easiest one to factor, so I'm going to start there. You don't have to do it that way. That's just the way that I like to approach it. So when I'm factoring the bottom of the right one, I have x squared giving me x and x. The sign in front of my c is positive, so the signs are the same. The sign in front of my b is positive, so they're both positive. Factors of 4 are 1 and 4, and 2 and 2. I need my factors to add up to 5. If I use 2 and 2, they won't add up to 5, but if I use 1 and 4, they will. So that bottom one is factored. So odds are something on the top will factor to an x plus 1 or an x plus 4 somewhere else. So let's move up to this top one. It does have a coefficient in front of the x squared, but it's prime, and that makes our life easier because prime only has one factorization. It's number times 1. So when I'm splitting, I know I'm going to have a 3x and an x. Now the sign in front of my c is negative, so that means my signs are opposite. So I'm going to have a plus and a minus, and I don't know where those go. But my c in this case is a 1. The only factors of 1 are 1 and 1. So I get to put a 1 here and a 1 here. Now at this point, I have to do some guessing on where I put my positive and where I put my negative. But look at the bottom. I had an x plus 1 factor in the bottom. So my first guess is I'm going to try and put the positive here and the negative here, simply based on how I factored another one. So if I put my plus here and my minus here, when I do my FOILing, I get my 3x squared, positive 3x minus 1x, that does give me a positive 2x, and then I have a negative 1. So it does factor appropriately. So I get to eliminate some of the guessing and checking simply by using the other stuff that I've already factored. All right, top left, I like it because, again, my a is positive, or is a prime number, so I know I'm going to have a 2x, and I know I'm going to have an x. The sign in front of my c is negative, so my signs will be plus and minus, so I'm going to have a little bit of guessing and checking with that. And then there's quite a few factors of 12. There's 1 and 12, 2 and 6, 3 and 4. And I do have to consider that I have this 2 out here as well. So when I'm doing my FOILing, I'm going to have to get to a positive 5 somehow. Well, if I'm getting to a positive 5, I'm probably going to start with either 3 and 4 or 2 and 6, to be honest. And based on the fact that I have a plus 4 down here, I might try that just on a whim and see what happens. So if I have to have a plus 4, that means I'm using the factors 3 and 4. So if I'm using the factors 3 and 4, that means this one has to be a 3. And since my signs have to be opposite, I would put a negative here. Now I have no idea if this is going to work. So if I do my first, that gives me my x squared, my 2x squared. If I do my outer, that gives me a positive 8x. Inner gives me a negative 3x. That does give me a positive 5. So this does work. Again, I eliminate out some of my guessing and checking by looking to see what other factors I have that I'm trying to cancel out. So this would be a minus 3 plus 4. Now I move on to my bottom one, which is my last one. My 6x squared, there's a couple different options for that, so I'm just going to put my x's in right now. This is positive in front of my c, so the signs will be the same. Since it's negative in front of my b, they will both be negative. Nice thing about this is 13 is prime. So 13 times 1 are my only two options. So now with my 6, though, I have 1 times 6 or 2 times 3 as factors of 6 that I have to put in here. Does anybody want to wager a guess at what I'm going to put where based on other factors that I have from other polynomials? Like, do I have any factors that have a minus 1 or a minus 13? I have that one. So I'm going to try sticking a 3 here. And if I stick a 3 here, that means I'm using the set of factors 2 times 3, which means I have to put a 2 here. And then I'm going to check it just to make sure. If I do my first, I get my 6x squared. If I do my outer, I get a minus 2x. If I do my inner, that's not working, is it? Because that makes it too large here. So that one didn't work. But, look, I do have a 2x minus 3. Does that work? Did I factor this wrong in my notes? Oh, I wrote it wrong. Sorry, guys. It's not 13. It's 3. There, I bet it works now. Negative 2. And then that'll give me a negative 9, give me a negative 11. And then that'll give me a positive 3. Sorry, that was my fault. I wrote it wrong off my notes. Oops. Okay, so let's look at it. We've got a 2x minus 3 on top. We've got a 2x minus 3 on bottom. We got an x plus 4 on top. We got an x plus 4 on bottom. We got a 3x minus 1 on bottom, 3x minus 1 on top, x plus 1 on top, x plus 1 on bottom. What does that mean? It equals 0, 1. That is true. Which one? It equals 1. Easier way to see that is if I had 2 divided by 2, what does that equal? 1. If you have the same thing on top and the same thing on bottom, you get 1. So yes, we just did all of that factoring so we could cancel everything out and get 1. I always found these problems a little bit annoying as a student because I'm like, man, I just did all that work for that lousy 1. But we did get to hone a lot of skills in terms of our factoring. So if everything cancels, you get 1. You are not going to get 0 on these unless the top has the number 0 times something. Like that's the only way to get 0. Questions? Obviously lots of factoring on that one. Okay, one more, and then we're going to go to division, which division really is just multiplication. All right, and there's F. All over x plus y times x plus 2y. I like to include this one because this one has multiple variables at play. X squared minus y squared over x plus y times x plus 2y over 2x squared minus 3xy plus y squared. What is the top left? The x squared minus y squared, what is that? It is x minus y, x plus y. We call that a difference of squares. So this factors into x plus y over x minus y. We have that x plus y on bottom. The top on the right, the x plus 2y is not going to factor. There's nothing in common between the x and the 2y, so it's going to stay. This bottom polynomial, though, is going to factor. We have a 2x squared as our leading term, so we're going to have a 2x and an x. It's positive in front of my c, so that means my signs are the same. Since it's negative in front of my b, they're both negative. And luckily, our last term, the c, is just y squared. So that means I'm going to have a y and a y. And I can check. First, outer would give me a negative 2xy. Inner would give me a negative xy, giving me the negative 3xy. So it does all work. And then I just look for what do I have in common with the top and the bottom. I know I have an x plus y and an x plus y, an x minus y and an x minus y, which leaves me with my x plus 2y over 2x minus y. Those are not the same. I can't pull out a 2. I can't cancel a 2. I can't cancel anything else. Don't do magic math and try and do anything like that. That's as far as I can take it. We're done with that one. Are there any questions at all on any of the multiplication problems before we introduce the division? Okay. There's not a lot of notes for division, just like there wasn't a lot of notes for multiplication. When you are dividing fractions or rational expressions, you'll have a rational expression divided by another one. What you do is you keep the first fraction exactly the same. You change from division to multiplication, and you flip your second fraction. So a shorthand way of kind of remembering it is you keep it, change it, flip it. That's what you're going to hear me say a lot. Keep it, change it, flip it. And then it's a multiplication problem. You have a few more stipulations in that. You also can't have c equal 0 at that point, but that's not going to really factor into your problems today. Keep it, change it, flip it. And again, we will start off with a number problem first before we get into slightly harder ones. And we won't do quite as many divide ones because, again, it's mostly multiplying. Keep it, change it, flip it. No matter if you have numbers only or if you have expressions, you keep the first fraction exactly as it is. So 2/7 stays. Keep it, change it from division to multiplication, and then you're going to flip your second fraction. So instead of 9/7, I'm now going to have 7/9. And then we go back to the stuff we were doing. What does the top have in common with the bottom? It has the 7, so we cancel those out, leaving us with 2/9. And just like with our multiplication problems that we were doing, a lot of times, a lot of stuff's going to factor out and cancel.
I have a question.
Yes?
Would it be easier to flip the second term before you start factoring and simplifying, or should you simplify before you flip?
No, you cannot simplify before you flip because then your tops and bottoms are backwards. So you always want to flip first and then do your simplifying. Great question. Yeah, because you don't want to simplify till you're already in the multiplication step. Now, you can do some of it at the same time. Like in this one, I'm going to go ahead and factor my top left rational expression because I'm not going to change, I'm not going to flip anything or do anything with this first one. So I'm going to go ahead and factor this top one. It's a difference of squares. X squared minus 9 can be written as x plus 3 and x minus 3. And all of that is over x plus 4. So I do go ahead and do the factoring here, but that's mostly just to save some space. So I keep this because I didn't change anything besides factored. Then I'm going to keep it, change it, so change to multiplication, and then I flip my second fraction. So instead of x minus 3 over x plus 4, I now have the x plus 4 on top and the x minus 3 on bottom. Now that I have it where I have flipped everything and everything is nicely factored, now I can do my canceling. X plus 4, x plus 4, x minus 3, x minus 3. So the only thing left is the x plus 3 on top. So sometimes when you finish, you're not going to end up with a fraction at all. We saw that earlier too when we got 1 and other things. I like the next example for a couple of different reasons. And I always make sure to include it because it showcases a couple of common mistakes that students like to make. The first is with our first rational expression, this whole left fraction. Notice we have a polynomial on top that starts with a w squared, and then on the bottom we only have w squared. There's some magic math that I've seen over the years where students are like, oh, we have a w squared on top, w squared on bottom, and they'll cancel it out just like this. You cannot do that at all. That is major magic math. We didn't factor that w squared out of all of the terms on the top, so we cannot do that. So I like to point that out. Hopefully, by showing that early, you guys will be less tempted to do that. The second is noting that our second fraction, quote unquote, isn't actually a fraction. It's just a whole number expression. And so just like previously, in order to make it into a rational expression as a fraction, we're going to stick it over 1. That's true whether that's your first term or your second term. If we would have had this first or second, in order to make it into a rational expression, we're going to stick it over 1. So now we're going to keep the first fraction. And either you can write it down exactly as it is first, or you can go ahead and factor the top. It's whatever you're more comfortable with. I like to go ahead and factor the top just to save some paper space. I know I'm going to have a W and a W. It's a positive in front of my C, so that tells me the signs are the same. Since it's a negative out here in front of my B, I know they're both negatives. So factors of 30 that add up to be 11. I have 1 and 30, 2 and 15, or 5 and 6, or 3 and 10. There's another one. Lots of factors of 30. 5 and 6 sure do add up to give us 11. So I'm going to have a 5 and a 6. So again, we didn't change the fraction at all. We just factored it. So we kept the first, changed the multiplication, and then we're going to flip the second one, which is why we'd stick it over 1. So that when we flip it, we have that 1 on top. And then I'm going to just expand the w minus 5 squared. I'm going to write it twice. That way when I go to cancel stuff, I can see what I have left over. Notice I have a w minus 5, a w minus 5, and nothing else. I have a w minus 6 left on top, and on bottom I have w squared times w minus 5. Again, they want you to leave your answers in the factored form, so I'm not going to distribute that w squared. I'm going to leave it factored out just like that. Any questions on these first 3 before we do one more quote-unquote Big Daddy problem? All right. Last problem. Right there. Number D, or letter D. 12x squared minus 22x plus 8 all over 7x. We're going to divide that by 3x squared plus 2x minus 8 all over 2x squared plus 4x. Do we notice anything about that top left polynomial? The 12x, they're all even numbers. That's exactly right. So I can factor out a 2. Remember, all the forms of factoring that we learned in chapter 6 will show up. So I'm going to pull out a 2, leaving me with a 6x squared minus 11x plus 4. All of that is over the 7x. Change it to multiplication, and I'm going to flip to where I have 2x squared plus 4x on top, and the 3x squared plus 2x minus 8 on bottom. So looking at the 6x squared minus 11x plus 4, I'm going to have to factor that. I know I'm going to have an x and an x. The sign in front of my c is positive, so the signs are the same. Sign in front of my b is negative, so they're both negative. So now we have a little bit of guessing and checking, or we can leave it for a minute and come back and see if we can factor one of the other ones easier. It's kind of your call. Do you want to keep factoring or factor one of the others first? Keep factoring. Okay. So factors of 4 are 1 and 4, or 2 and 2. Factors of 6 are 1 and 6, and 2 and 3. Since the signs are the same, I'm going to need the factors to add up to 11. So they add up to 11. Bless you. Like, I don't want to take 6 times 4 because that'll be too big. And if I have 6 times 1 and 4 times 1, that's going to give me 10, not 11. So I'm probably going to use the 2 and 3 and the 2 and 2. Just guessing. So if I put 2 and 2 here for my 4, then it doesn't matter where I put my 2 and 3 here. And let's test it. We get 6x squared minus 4x minus 6x. That didn't work. So the 2 and 2 did not work. So let's see if we did 4. If I did the 4 here, notice that would give me 12. That's going to be too big. So if I put the 4 here and the 1 here, notice what happens is I get an 8 and a 3. That does give me my 11. So it's going to be 2x minus 1 times 3x minus 4. 7x just kind of hangs out down there. He's not doing much. What about the top right? We have 2x squared plus 4x. Yeah, 2x can come out of that, leaving me with an x plus 2. And then down on the bottom, we're going to factor some more. My first term is a 3x squared, so I'm going to have a 3x and an x. The sign in front of my c is negative, so I will have a plus minus. So this is where I'm going to look and say, okay, well, I know I have a 3x, and look, I have a 3x minus 4 over here, so I'm going to start with that and see if I can't make that one work over here. So if I have a minus 4, that means this has to be a plus 2. So that would give me a 3x squared. That would give me a 6x positive minus 4x. Hey, that would give me the plus 2x in the middle, and that does give me the minus 8. And then I can cancel some stuff. I have 3x minus 4 on top and on bottom. I have an x plus 2 and an x plus 2. What else do I have? There's one more. Can't cancel the 2 because the 2's are on top and the 7's on bottom. 7 and 2 don't cancel. The x, that's right. There's an x on bottom and an x on top. So that leaves me with 2 times 2 on top, which is 4, times the 2x minus 1, all over 7. And in my handwritten notes, I did go ahead and distribute that, but I think Pearson will take it either way. I didn't do a problem like this in the note or in the homework when I did them earlier. But it should take it either way, on Pearson.